Hi, in this video, we're going to be looking at a trigonometry three-dimensional video. Looking at the following question, and we're going to read through this. In the figure, points K, A, and F, if we look at K, A, and F, they lie on the same horizontal plane, and TA represents a vertical tower. They give us that angle ATK is X, KAF is 90 plus X, and KFA is 2X. And they've also given us the restriction that X is in a range of 0 degrees to 30 degrees. Also given side TK is 2 units. So our first question here is to express AK in terms of sine X. So we're going to firstly zoom into this triangle that I'm going to highlight for you, as you can see, TKA. So if we look at triangle TKA, it is a right angle triangle. So we can use SOHCAHTOA, which is your sine, cos, and tan. So I'm going to look at what the question wants, which is AK. So if we focus on AK, and you'll notice in terms of the angle that is given, X, AK is the opposite. And if we look at what is given in this triangle, TK, which will be our hypotenuse. And if you're using X, Y, and R, then what we have is R, your radius of 2, and opposite angle T, we could use Y, which is Y over X. So I'm going to use opposite and hypotenuse. And from the definition, sine X is equal to opposite over hypotenuse. Now, looking at the triangle, the opposite is AK, which we're going to substitute. So we got AK and the hypotenuse is 2. So we have opposite over hypotenuse. The AK is the opposite side, and the hypotenuse in triangle TKA is 2 units. And what we're going to do now is cross multiply, and that will give us AK is equal to sine X times 2 is 2 sine X. So we've answered the question which says express AK in terms of sine X, and we have AK is equal to 2 sine X. We're now going to go to the next question. I'm going to delete that. And the next question is worth actually 5 marks, which says calculate the numerical value of KF. So we're going to go to KF, and KF is found in triangle KFA. So we're going to highlight the triangle, and you can see I've highlighted it in green. So we want to find KF. So we see the angle opposite KF is known to be 90 plus X. And also remember, in our previous question, we found out what is AK. So I'm going to make a note of that. We found out that AK was 2 sine X. And by using the sine rule, which is KF over sine of 90 plus X will actually be equal to 2 sine X, because we have that side, over 2X. So we're going to implement the sine rule, and there we have it, that KF over sine of 90 plus X is equal to AK over sine 2X. Now, I did tell you that we know what AK is, but remember that sine of 90 plus 2X is a co-ratio, so we can simplify that as well. So we have KF and sine of 90 plus X using co-ratios will be cos X. Remember, in the second quadrant, sine is still positive. And then we are replacing AK with 2 sine X, because we found AK in the previous question. And then I'm going to use my double angle formula and expand sine 2x is 2 sine x cos x. You'll notice that 2 sine x and 2 sine x, we can cancel that off. And then we're left with kf over cos x is equal to, well, everything on the top canceled off, so we can say that we can put a 1 here. And if we cross multiply that, we're going to get kf times cos x is equal to 1 times cos x. And then we're going to divide both sides by cos x. And you will notice that kf will actually be equal to 1 unit. And that completes our 3D question. I'm just going to erase that and get it done with the computer. Thank you.